array, increasing the size of subdivided array, and then arranging and sorting it individually, like individually sorting every subdivided array. So at this position, when only one element is present in the array, the it is already sorted. Okay. At second iteration, 5 and 13, this is already sorted because ARR of 5 is less than ARR of j. Okay. But in this case, 5 and 13, 5 and 13 are sorted, but 1 is not sorted, so it will just compare these values. Okay. 1 and 13, then it will get swapped. We will get 5, 1, 13. Okay. Then again these values will be swapped, compared and swapped. Then 1, 5, and 13, we will be getting these values. Okay. In this case, after this 1, 5. Okay, new move to new page. So previously we got our array sorted in this way: 1, 5, and 13. But uh, 12, 25, and 10 are still available. So one now we will compare 1, 5, 13, and 12. Till now all arrays sorted, but while comparing these indexes, we will have to shift position of 12 and 13 and 13. This is the new subdivided array, and till this index now our array is sorted. And okay, and that's how insertion sort actually works. And okay, let's try and implement it in this session itself. Online compiler. ARR, uh, let me check. Let me check for insertion sort. I forgot some values like almost ARR into ARR. Um, like for insertion. Okay, size and yeah, I and J. Um, okay, so in this function, we are actually doing is declare some values I comma j comma current. So starting our loop I equal to 0, I less than n, I plus plus. So what we have to do is save the value of current index in the value current. So int j equal to I minus 1. See, see. Now come start our while loop and do these steps until ARR of J gets bigger than the current value, or and J is greater than and equal to 0. Because why we did J greater than or equal to 0? Because we are doing from this index, we are going in this position. Okay, we are comparing values from this index and this index, then this index and this index, then this index and this index, and so on. So we are just going backwards from I to 0. That's why. So if such thing happen, J plus 1 equal to ARR of J. If we actually found a value, okay, there is. So what if we found a value that is actually lower than the previous value? Okay, at this position, the values we have to swap these values. We are comparing this value and this value. This value is greater than this value, so we have to swap this position to this position accordingly. So what we do is we just move all the values till this position to a next position, like 13 to 12 and so on, till all the array values got sorted. Okay, and at last, okay, at last position, because I is at this position, so current is also saving this value. So at last, after all the conditions, like all the values that are less than that are greater than current are moved, and we encounter a value that is less than current. Okay, our while loop is actually working till AR of J is greater than current and value of J is greater than 0, because we initialize it to I minus 1. Either this fails or either this fails. But until then, switch all the values from at this position to the next position. Okay. So there will be a case when one uh, there will be a case where we will be getting 1 comma 5 comma 13 comma 13. We will be getting this array also till we are present in this loop. Okay, but but okay, but after exiting this while loop, what we do is change the value of J plus 1, okay, to current. Why? Because our J minus minus at for this position, like 1 5 13 12, j j will be at this position. Okay, it will go to this position, compared, found it of greater value, then swapped 1 5 13 13. Okay, compare these values, but this value is actually lesser than this value, so j will be at this position or not. Let me see it again. J plus 1, and what is present in the dry run. Key iterate from 1 to 1. Compare the current key to its predecessor. If the key element is smaller than its predecessor, compare it to the elements before. Move the greater elements one position up to make space for the swapped element. Okay. J would be at I minus 1. J would be at I minus 1. I will be at this position. So yeah, definitely J minus 1 at this position. Okay, 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 okay. We will be getting. Sorry, just a second. Actually, I is at this position. J is at this position because J equal to I minus 1. So we compared this value and this value, but J actually got a decrement, and we encountered a value that is smaller than this index. This index. So we get our j plus 1 to this position, and at this position we are just swapping, like we created a space. When we have to move something from this position, like this position to this position, what we can do is move this value to here, this value to here, this value to here, and this value to here. Save this value in a temporary variable, and then after doing it we will find that these two values are same. So change the value of temporary variable to this variable, and we will move our values one index ahead in this case, and one position behind, like from starting to end index. Same thing is happening in this loop. Okay, take this as an example of a question. We are given an array of 5 elements. Move all the elements to next position, and change the value at, or change or put the value at last index to the first position. Okay, this while loop is actually this for loop and while loop together is doing this thing, but in a sorted way. Okay, this thing is actually moving all the elements all the elements till a position where we have to actually fit our new element, the encountered element, that for at the position where all the elements to the left side are lower than that element, current element, and all the values greater than current element would be at right position. That's why at that in these 3 or 4 lines, what is happening is we are shifting all the values from one point ahead, like moving one point ahead, because we have saved the value at this position into our current variable. And after we find a appropriate index where all the values that are less than the current value is present and greater than the current value is at right, we will place the value of current at that index. So one sorry 5 elements, we have to move this element at last position to a third element, then move fourth element to fifth element, third element to fourth element, then fifth element will be moved to third element. And that's how insertion sort works actually. We can try run it. That's how insertion sort works. So that's all for today's session, a hectic session because we have discussed so many new things. We discussed two main sorts that are commonly used, the merge and quick sort, that you would definitely be encountering in any question or any exam for company tests, like any company aptitude tests, or in case of MCQs also, you would be getting questions related to merge and quick sort. So I think merge and quick sort are definitely covered in details. Insertion sort is not that much important accordingly in comparison to merge and quick sort, because those are the sorts with like a lower time complexity, so that is favorable. Insertion sort has a larger time complexity, and we can see this here. I have saved, like, yes. For insertion sort, the best case is O of n, average case is O of n square, and worst case is O of n square also. But for merge and quick sort, O of n log n, O of n log n. Okay, merge sort gives us O of n log n in best, average, and worst case, and quick sort gives us O of n log n and average, in average case also n log n. But in worst case, it gives us O of n square. That's why quick sort and merge sort are the most preferable. Till now, all the sorts that we have discussed, and I think it's already 10:42. We have to now close the session because
Yes,
it's a
yes, yes.
sleeping time now.
Yes. Okay, so thank you so much for the wonderful session, Simarpreet, and I hope the audience enjoyed it a lot, and the people are still here, and that definitely says that the session was quite interesting.
Actually, thanks for being present here till now, till end. I think I will have shared a good information that will help you in any of the case or exam or interview. And if that happens, please ping me for telling the news that yeah, this question appeared, so that I could write it in our list also, that yeah, this is definitely a good question, we covered it right, and I
Yes,
will share it with my juniors also.
yes. So thank you so much everyone for attending the session, and thanks again, Simar, for the wonderful session, and good night to you all.
Yeah, good night, everyone.